it's become an annual event for Rajesh Parikh and me to do a trends document and trends podcast for the upcoming year. Today is getting close to end of 2024, and Rajesh and I just published our enterprise data and AI trends document for 2025. So it gives me great pleasure to welcome Rajesh once again for second year in a row to talk about what were some of the major trends that we have identified, which we feel are going to be very transformative next year. So, Rajesh, thank you so much once again for taking the time and collaborating on the document, and now coming on this podcast to talk about what are some of our views and findings. So, welcome.
It's a pleasure, Sanjeev, to be back here again and collaborating with you on the document, second year in a row. And it's even more enthusiasm because of the fact that we've been also working on the ground on many of these things, and we see that coming to fruition and a validation as well as we go through this document.
Amazing. Thank you so much. And by the way, for viewers who don't know Rajesh Parekh, he is a founder and CEO of Synepia Technologies, which is doing some pretty groundbreaking work in the space of AI. So he's a visionary that I go to when I have questions about what's happening in the world of AI. So with that, so we're going to go through this quickly because we have a lot of predictions to talk about. But what we decided to do was let's first take a step back and see how did we do in 2024 predictions. Were we on the dot when we recorded this in end of December 2023, or did we miss a mark? In 20 for 2024 prediction, we had divided these into three buckets called rising, stable, and declining. So there was a little bit of controversy about how people view this. There'll always be controversy. Even today, we are going to talk about people who are skeptic about some of the things that we've identified. But that's comes with the territory. So, but this year we decided not to break it down into these categories. But before we go into 2025, here are the 10 predictions that we had made. Just the way things fell in place, almost all the rising trends, not almost all the rising trends were pertaining to AI. Whether it was the stack that converged AI and data, or the agents, or personalization, or governance. All the stable ones happen to be the data ones. So, data and cloud. And then we identified two declining ones called modern data stack and data mesh. So let's do a quick check, pulse check on how did we do last year. So I'm going to start with you, Rajesh. What do you think we got right? What we didn't get right?
Yeah. As you would expect, many of the trends that we've been talking about have a runway of 12 months, and obviously, therefore, you don't talk about trends which are very far-reaching. So they have to be on the ground in some form, and then you're basically talking about how would this trend pan out in the next 12 months, right?
Hmm. Hmm.
So, to my happiness, almost all of them except for cross cloud have turned out to be pretty close to what my own expectation on how these trends would come out have been, right?
Hmm.
Particularly the one that I would want to mention are AI agents and personalized AI stack, as well as the intelligent data platform, because when we started the year, the whole scene was modern data stack at the peak of its hype, and there wasn't really a term called intelligent data platform when we made this prediction, and this has really come true. And there are many vendors who have announced the products in this space over the last 12 months. AI agents again was another one where there was a murmur when we actually made this, and it sounded very fancy and new at that point. But as we end the year, agents are all over the place in all conversations. So this has been such a nice catch if you look back at the time we made this prediction. Personalized AI stack, AI governance, they are both working out as well. As we know, the scaling laws have ended, and the post training is where most of the meat is now, even in the frontier labs, right? And the way I see it is, as we move, and we've seen a lot of action even in the open source because of Meta, DeepSeek, and various other OSS models, which bring the promise of the lab enterprises or the leading enterprises who want to do their own post training can actually do that. We saw LinkedIn publish just today a post around how are they building agents by personalizing the lemma for their unique requirement of serving professional agents for LinkedIn, fundamentally, right? So this has also come out true, I think the rest of the trends, declining ones. I mean, there is a good amount of consensus today. What do you
Yeah.
think, Sanjeev?
Yeah, and soon after we had published this, CEO of DBT Labs, he basically said, modern data stack is here to stay, it's not going anywhere. That was in his January newsletter. In his February newsletter, he wrote, modern data stack is dead. And Ben Stancil, all these people, they all actually started saying the same thing. And I strongly feel that AI agents are actually going to take the place of modern data stack, but it won't be in the next 12 months. There are a ton of skeptics, and there's a lot of like criticism. AI agent is a hype, so time will tell. But we predicted in December 23 this will be a big trend, and it is a big trend today. Small domain specific, task specific models are a big trend these days. And you mentioned DeepSeek, Gemini, Flash thinking model just came out. OpenAI O3 model just came out. These are thinking models, System 2,
Yeah,
and they reason. And so in my opinion, I think we are at the cusp. We are in early stages. So I don't see these as hype technologies. The two that I'm really excited about are the intelligent data platform and unified data plane. Those and metadata plane, those absolutely took off this year, and they are
yeah,
also part of our 2025. So let's go through 2025 trends so we can then talk about these exciting developments that happened this year. So in 2025, two changes. We are not calling it predictions, we're just calling it trends. And second thing is we have now divided it into three buckets: applied AI, which, as you can see, it means we are applying the, AI to production use. I think, Rajesh, we would agree only 10% of AI projects went into production, would you say?
yeah, I agree. Yeah,
Okay, so we are hoping this number is going to go only higher. Then, of course, we have our data predictions, data and operations. And then we have this very exciting space of moonshots. It's like, where is this technology going? These are some risky bets, but they can be even more transformative than the regular changes that take place in the space of data, for example. So with that, here are our 10 trends. You can see we've got four in applied AI. We start with agents, multi-agents, agent management, a lot of agent stuff, and then into what we call personalization of AI. We are calling it task specific models. When we get to data, we will still talk about intelligent data platforms because that's work in progress, but doing more with unstructured data and preparing our data even more, such as data products for AI use, is the next set of three trends. In Moonshots, we talk about how these agents are going even a step forward, but I will leave that discussion towards the end. And with that, let's start with the first category of applied AI. As I said, we have four trends that we are saying. So I'm going to start with agents all the way because we have a lot of material to cover. So we've got a few slides on this. Rajesh, walk us through why you feel agents are important and add some color to this topic.
yeah. So first of all, we've had automation as a theme even before AI.
Yep.
We've had
RPA,
RPA and
robotic
many.
process automation. Yep.
So, what is the new thing here? Oh, by the way, the agent as a definition has been around since 1950. We've had agent definitions changing name to in some form in 1990s, for example, right?
Hmm.
So, the agent as a term also is not new,
Hmm.
right? What is really new here is the fact that we now have LLM sitting at the core of the agent, which is able to do many things which we were not able to do with the RPA earlier or the earlier form of agents that we had. And some of the key highlights of the things that we can do today is one, of course, and the most important one is these LLMs are essentially able to uh, understand and follow instructions in natural language. That's a very important piece of how as humans we deal with each other today. We talk to each other in a natural language, comprehend, instruct, all of that. So these models have become pretty good over the last 1 year. In fact, when we started to now, these models have become a lot better with instruction following,
Hmm.
right? So that's one key capability that changes the way we build these automations in the first place. We also saw over the year, although this was not the story when we started the year, is can these agents really reason? And there's been a lot of debate around it that these are stochastic parrots versus they have no idea about the reasoning. And all of that is really true. But the fact that we now have figured out how to pass chain of thoughts, a sort of a variation of how we were instruction tuning earlier, to pass on uh, a set of steps which can help these models break down complex tasks into a series of steps. And what we're also seeing with the R3 as well as the DeepSeek R3 announcements and various others is that these models are not just able to generalize the regular tasks, they're also able to generalize the reasoning tasks. They're still not there, but they've gotten a lot better, right?
Hmm.
So today, the way we look at these programs is maybe these programs will have a split of human-induced reasoning in the agent program versus using the or offloading the reasoning itself to the model. Now, these are the trade-offs, but at the end of the day, the point is these agents can perceive its environment, they can reason and break the given tasks. You could use a strategy of a software version of instruction to reason, give the reasons to the agent, or you can let the LLM or the model itself reason it. Now, these are choices that an agent developer would make. But fundamentally, at the end of the day, do what with all of these is really take actions. And these LLMs have also gotten better with the structured data output, the function calling capabilities, and all of that, right?
And real time
And real
APIs.
time, absolutely.
Yeah,
And
they're
real time is
correct. They're working in real time. So the four things that we pointed out in the frequently asked questions on AI agents was the four defining pieces are sense, reason, plan, and act. So you sense the environment, you reason what's going on, you create a plan of action, actually many plans of actions. You go through different plans and you see which one is the best, and then you act upon it.
yeah,
So this is how the RPAs of the world are actually not that sophisticated because RPAs work on fixed rules,
yeah,
but agents are sensing and then doing reasoning to plan
yeah,
out the next best action.
yeah,
And so that's why they're far more
yeah.
sophisticated. So go ahead.
No, just to add to that, the degree of uncertainty, because at the end of the day, it's the next token predictor, is pretty interesting. Also, because that uncertainty also helps it to handle situations which, in the case of RPA, you would have to think through almost all the possible trajectories and rules
Mhm.
and key in, which kind of makes the agent fairly brittle. These agents give you that flexibility along with a little bit of an uncertainty, and that's really the trade-off that you're playing when you're looking at an AI agent.
Yeah, that's right. And I see you put common misconceptions here because just in the last 2 days since we've published our document, people are saying, well, agents are just function calls, they're just wrappers
Yeah,
on LLMs.
yeah,
So, yeah.
yeah. Really, I mean. That's how people started building the agents, and maybe this also reminds me of the early days of programming where everything was a function
Yeah.
when you wrote a program, right? But as we started going through, we started building sophisticated programming languages with objects and model every object in the world and the operations that we do on it, right? So we're probably in that same state here where the agents do a lot more. They, yes, they have function calling, but they're not just function calling is not the same as agent. Yes, they do have LLM under the hood, and both of them are true, but they're not merely an LLM agent. They bring in many more capabilities. For example, agents are stateful, LLMs are not. They also bring in the capability where you're essentially talking about how can you make these agents use tools, not just one tool, but actually plan a series of steps. Let's say you create a sandbox, you run the code, you go back, close the sandbox, or potentially go back, update the code, rerun it, and then close it, right?
Yeah.
So they can follow a fairly complex set of tool calling chain as well as we go through that almost. And we've
Yeah.
seen this with the browser agents and the desktop agents that got announced fairly recently by many of the vendors, right?
Yeah.
So these are few
Yeah.
capabilities, but there are also more that can come in the future where these agents could potentially self-improve. Uh,
Yes. And we will talk about that
yeah,
self-improvement. And okay, so we have there's a link to the paper. So if you go
yeah.
to the site,
One
okay,
more thing that I want to talk about,
yeah.
probably from a use case point of view, there are going to be a lot of agent startups. The products announced, they have been announced in 2024, and there'll be more that will be announced in 2025. And I'm calling all of them as off-the-shelf agents, which are well-defined boundary, let's say an SDR agent or a specific use case for, let's say, a content publisher agent, so on and so forth, right? But the more importantly, from an enterprise standpoint, yes, those are the ones where you make a build versus buy decision. But there are a lot of nuanced and long tail and personalized agents that enterprises would be building over the course of next year if they really want to build agents that would fit in their existing workflows, which may not necessarily fit the boundaries that the startups are building on today, right? So I mean, there are many ways to categorize the agents, but one of the ways is, are you going to have the well-defined boundaries, or are you going to be building many personalized? I think you're going to be doing both in 2025.
That's very interesting. In fact, to see how much impact or how much enthusiasm there is for agents, and this is why I'm mentioning this is like don't take our word for it. Like if you see the CEO of Salesforce at Dreamforce this year in October of 2024, he announced that Salesforce created a bunch of agents like SDR agent you mentioned. They were hiring 1,000 salespeople to promote and sell agents.
Yeah,
Last week, he came back and he said, sorry, it's not 1,000. I misspoke. I'm hiring 2,000 people just to sell agents. So it's Salesforce sees this vision. I mean, that tells you
yeah,
that, this is much bigger than we
yep.
expect. So, okay. So enough about agents all the way because we're still not done with agents. We're now talking about multi-agent. So Rajesh, I'm curious, why not just have one agent that does everything? Why this concept of having multiple agents?
I think again goes back to, if you go back and look at the software paradigm, we used to write single program, one file, a few files, and then we started breaking it up into multiple modules, multiple processes, so on
Hmm.
and so forth. And the reasoning is basically, as you keep building, and a single agent does many things, these things become far more complex to manage and troubleshoot in real life. That's one issue,
Hmm.
but also
Hmm.
the fact that as they become complex, they become also more prone to making errors. So one of the simple thing here is, even though the models can make errors, the question is, how do I contain the error in one confined block of a single unitary or a single set of tasks that I have assigned to this, or a set of tasks that I've assigned to a single agent, right? So take the example, for example, if you're a content agency, you would probably have somebody doing content research, somebody creating content, and somebody doing the publisher work, right?
Hmm.
Now, all of this comes together in a real agency and not just a single human doing all the work, right? And this would also apply to agents. They would, over time, specialize. They will have clear boundaries of what they're good at and tested for. And for every other thing, they would basically take help of other set of agents, fundamentally working in a
Yeah.
team.
You know what I find super interesting is, so in this example where we took the example of content publishing and we said there's a research agent, so that's number one. So interesting thing is all the websites have up to this point been built for human consumption, but we are going very rapidly into the world where an agent is going to crawl through the website autonomously, extract
Yeah.
that data, use LLM to summarize that data or find out some key facts, and then send it to the next agent, which is going to create this content. We are already seeing this happen at scale. We just don't know about it. It's just happening underneath. There are a lot of
Yeah.
Reddit content that today is being written by these agents.
Agents. Yeah.
And so this access to websites is going to be more API driven than human. Would you say so?
Yeah. Oh, absolutely. In fact, a few months back, I did mention that would we need another internet for agents because they're going to be driving bulk of the traffic on internet as we go
Hmm.
forward. And
Hmm.
humans, if they're going to be using the human internet, then the humans would probably be minuscule part of that internet. We already know lots of boats out there, whether they're AI or not, and this is only going to exponentially grow as the agent trend plays out over the next few years.
That's great. So let's move on because we are going to come back to this when we talk about our last trend in Moonshots, which is how these agents communicate with each other, because
Yeah,
that is still a bit of a challenge.
yeah.
So the next thing that obviously that takes us to is okay. So if agents are going to be that pervasive and we're going to have a system comprising of multiple agents, how do we build one? And for that, we see there is going to be a rising trend towards agent management system. The first time we started looking into this, the question came, wait, there are already a ton of agent frameworks. Everybody has some sort of an agent framework. So what's an agent framework and what's an agent management system, Rajesh?
Oh, absolutely. And you said one agent, and that's true. But the question here is, are enterprises going to be building one agent? We believe that enterprises will build hundreds of them,
Hmm.
right? And the first challenge you create when you build hundreds of them is now you have a problem of scale and
Hmm.
complexity of managing these hundreds of agents that you're building, right? So that brings in the concept of agent management system, where you're basically saying that can I build a production line for building agents themselves,
Hmm.
right? And here we're talking about can I build hundreds of agents over the next 1 year, right?
Hmm.
If that is really what your goal is, then the agent management system becomes pretty critical to achieving that goal. Over the course of 2024, what we really did is we built a lot of frameworks. We understood that frameworks are important because you need state, like we discussed before, for building the agents. The agents need to use tools, states, they need to interface with multiple LLMs, so on and so forth.
Hmm.
However, that wasn't sufficient to push the agent to production, and like we discussed, there are only 10% which actually made it to production. So over the course of time, we realized that these systems are stochastic, and testing them can be a lot bigger challenge than actually building them, right? And hence, a lot more focus towards the second half started coming on agent evals, evaluating automatically. How do I really test these agents? So those are those brought in the other pieces, and then obviously with anything that you build, you need to start deploying, and a critical piece is monitoring here also because, like we said, these are unreliable core. We're trying to build a
Yeah.
reliable system on top of an unreliable core, and unlike the normal software where you give one input and the output was always certain given a specific input, in the case of agents you can give the same input and get multiple output variations, different output at different times, right? Now, how do we really monitor what is really going on here? And that's really a very important piece as well. So as you realize, we just cannot skip any of the pieces as we go forward,
Yeah.
and then we want to scale it as well, and that is really where the agent management system enters. Here we've defined six steps or six pieces of components of the management system. You need an agent builder for sure. This could also be a no-code version or a framework version of the agent builder. You need an agent registry. Agent registry essentially is a repository of agents.
Hmm.
This is essentially where you have all your access controls, governance, who has access to what, so on and so forth. That's your agent registry. Then you have the agent playground. This is really for carrying out the initial smell test before you even put it to production. Right? You do manual checks. You can test it via an interface, give your prompts, and check it out whether the agent is actually behaving the way you expected it to behave. Then there are agent experiments. This again is about automating the process of testing for hundreds of different prompts for which you expect the users to be using this agent. And that's the automated evaluation piece that needs to come. Deployment and monitoring, as we discussed, is important because once you've tested or you're even testing in staging stage, you need the deployment to happen on the cloud and test it for scale, latency, and the other non-functional
And yeah,
requirements as well.
as a container orchestrated by
Container also.
Kubernetes with an
And
endpoint.
finally, monitoring. You need KPIs for every question. What was the answer, and how many did I get it right, or how many did the agent get it right? How many did it get it wrong? And what went wrong? And then how do I improve it in the next iteration? And that's really where the monitoring plays the role,
Yeah.
right? And chat UI is essentially the consumption interface. Now, this could have variations, but there are some popular templates off late, so we have put that as part of the management system for rollout.
Yeah, so this is a great explanation. Thank you for that. Agents actually create some new kind of challenges that we've not had to face. For example, if you're building these agents for a specific enterprise use cases, then that evaluation monitoring becomes so important because we see a ton of benchmarks every day. There's some new benchmark. So if a models are compared on, say, math benchmark or some other benchmark, those are standard benchmarks on generic models that are trained on all of world's data. But when you get to the domain, you have
Yeah,
specific needs. So you need to first of all create your own evaluation script, which does not exist in the public,
yeah,
because it's very specific to how the workflows and the processes work inside your particular department. And then because these models are probabilistic, they can randomly give different answers. So you have to constantly monitor and make sure that they're not hallucinating,
yeah.
right?
So I
So
think in summarize, basically, this just scales up the whole productionizing of agents
yeah,
a lot more reliably, contextually to what an enterprise needs, but also the time to deployment. It just speeds up the time to
yeah.
deployment if you've already figured out that you need them anyway.
Correct. Yeah, a very good point. Yes, because cost is such a big issue.
Yeah,
And so, okay, so we can go on a tangent. We can talk about cost of tokens
yeah,
going down and GPUs, but let's stick to this our topic because we just talked about how this can be challenging when you start creating what we call task-specific models, which is the fourth and the last of the trends in applied AI. So here, what we are saying is that organizations are taking a base model. Maybe it's an open source Meta's Llama 3.3 with its published weights and all, and then we're going through some series of processes. And what comes out on the other side is your small language model or your task specific or domain specific model. So Rajesh, what are these three steps that we see between a base model and the task specific model?
yeah. So this is essentially popularly called post-training. I mean, there are two pieces here. One is the post-training alignment, and the second is the continual fine-tuning, which is more of, let's say, a specific task you want to fine-tune for a new set of instructions. add a new set of COD prompts and train it for that, so on and so forth. Or let's say you have your own policy of safety, and you don't want the model to use the generic policy that, let's say, the model provider has trained it for, and you want it to work for your specific policy. Now, all of these are cases where you would need fine tuning. uh, but there are multiple ways to do it. One is clearly the first two steps that you see on the slide, which is the supervised fine tuning. This was the original one which most labs, foundation model labs, did post the pre-training model. But essentially, you start with two kinds of models. One is the pure base pre-trained model.
Hmm.
The other could be an instruction tuned model, or what we call the instruction following model. Now, you can start with either of the two and then further tune it for a set of or a bunch of specific requirements that you have as an enterprise. For example, if you're somebody like Uber, then you would do this step to make sure, and you're building a customer support uh, agent, let's say, then you would essentially want to do this for making sure that all the customers nuances that you have for an on-demand service like an Uber would essentially be handled, and the model is actually fine-tuned for that particular context. There are two stages here. One is what we call the instruction fine tuning, or the further instruction, where we have the input output pairs of, let's say, the kind of customer support tickets that were raised and the nuances, and what is the action to be taken next, right? The answers for those, that could be one of them. The second is also, and now we probably call it COT, or chain of thought reasoning, where you don't just show the model, the input and output pair, you also show the rationale of, or the breakup of what are the intermediate steps that need to be performed, or that need to be present for the output to make sense, right? For example, if you take a math question, then the CO2 would basically specify all the intermediate steps that a
Hmm.
student should write for getting the right answer, right? So that's really a COT. So you would have trained the SFT, or you would now at this point you have an SFT model. Now you put this model through an iterative test in the RL fine tuning stage, where you have a teacher
So,
model or a reward model,
so
and the model,
reinforcement learning.
it's called
Reinforcement.
reinforcement learning fine tuning.
Yeah.
There are various methods here too, but fundamentally, the moot idea is that the model is sent a bunch of prompts. The model generates many outputs, and the reward model essentially, or the teacher model essentially, rewards or penalizes or scores the output that the model has generated. And that best answer is then, preferred answer is then fed back to the instruction tuning data set, and that's how at the end of it you have a model which is more aligned and safer to the outcomes that you expected of those tasks, essentially.
I have
So
a
those are,
question. Yeah.
yeah.
So those steps. So I have a question for you. We in this step, one thing that we see quite a bit happening this year, and it's I'm sure it's part of this, is model distillation. In fact, just last week I was at AWS reInvent, and there was a huge amount of discussion on their model distillation, taking a large model and then getting rid of what you don't need into a much smaller model.
Yeah.
We see this continuously. A 70 billion parameter model is distilled into 7 billion or 1 billion, and it still performs equally well. What is
Yeah.
model distillation? Where does it sit here?
So, so essentially, I mean, the idea is pretty simple, which is that you have a very large model. Let's call it a teacher LLM or whatever, like GPT-4 or
Yeah.
whatever. Right now, by the way, this trend is very interesting because, and we actually talked about the fact that the real models are which are valuable and viable are expected to be below 100 billion parameters,
Hmm.
where the costs are more justifiable.
Cost is
Because you then work,
justifiable. It can run on edge devices, my cell phone, laptops. I don't need a big
yeah.
farm of
And,
GPU.
and that trend really played out. For example, GPT-4o is a distilled model of GPT-4.
Hmm.
Or likewise, Claude 3.5 is a distilled model of Claude Opus. And this trend continues across the board, which really means that you basically train a smaller model for all the tasks that you expect this model to perform, distilling the answers, or let's say the data from the teacher model.
Hmm.
and then training the smaller model on that refined subset, essentially. So it covers all the tasks landscape that you really want, but it also trims out all the unnecessary things that you really didn't want of the model, which many of the large models are really trained on pretty much all the data that exists out there,
Hmm.
right? So that's how you're compressing the model size and making them more valuable for the task that you expect them to work for.
Yeah. Okay, perfect. The cheaper you don't
Yeah.
need GPUs, you can
Yeah,
run it on
and they're becoming
CPU.
pretty reliable with every new
Yeah,
version of these models.
amazing.
So we expect
Fantastic.
this trend to stick and
Yeah,
continue. So while people may build, and by the way, we didn't see GPT-5 coming. So even
yeah.
if theoretically they have built, that would still be used for distilling and creating smaller models.
Yeah. Very true. Great. So with that, we change tracks and we move into data and ops trends. There are three trends we talked about here. So let's start with intelligent data platform. And I mentioned a few minutes ago that I was recently at AWS reInvent and they announced this whole unification of all their data, AI, machine learning, analytics into one common UI. It's called SageMaker Unified Studio, which sits on top of SageMaker Lakehouse, which has its own catalog and both technical catalog and a business catalog. So this was actually quite a remarkable change from AWS because up to this point, AWS used to say, we are the platform for builders. We will give you 15 different databases. We will give you three different ways of doing Kubernetes and five different ways of doing this and that. You can figure it out. Build the best solution you can. But now they've gone into this whole unification aspect. Before that, Google earlier this year at Google Cloud Next, they announced the same thing using BigQuery as an engine. In May, Microsoft Build took place, and then Ignite later that year. Microsoft Fabric is yet another example of an intelligent data platform. And so the other interesting thing that Rajesh had noticed was uh, Microsoft Fabric announced One Lake, which is the unified data plane that has structured data and unstructured data. The native storage is in Delta open table format, but then at Build, they said, if you want, you can store it in Iceberg too. So Iceberg, in my opinion, was a big winner in 2024 in the open table format. That is the default format even for AWS's new SageMaker-based unified Lakehouse and Studio. Uh, Also, Google supports all three. But other than this metadata catalog, which became so important because Snowflake announced Polaris, and Databricks already had Unity catalog, but then they announced an open source version of it. So we've now got a standard for technical metadata, which is an Iceberg REST catalog. But that's only one part of this unified metadata plane because that's at the technical layer. Above that, you still need the business layer. And so you still need a business catalog. So you have third-party catalogs, Collibra, Alation, Atlan, Informatica, but then you also have Snowflake announced Horizon. Unity also does business metadata. You need that because if I'm going to use AI to ask questions to my data, and I ask a question like, show me the combined sales of this SKU in this region for this period or for the last fiscal quarter. How does this English statement get parsed into a sequel or some sort of like an understanding of what's a SKU, what's a quarter, what's a region? For that, you need business metadata.
Yeah,
The other thing
absolutely.
that Another thing I just one last thing I want to also mention here is, and then I want to hand it over to you because this space is expanding like crazy,
Yeah,
is the whole access control, access governance, personalizing the user experience. So
yeah,
I can see things that are relevant to me. So for me, a particular SKU maybe more important in my region than to Rajesh. He may have different SKUs. So that's why this whole metadata plane becomes so important. So let me stop here. And Rajesh, what are your thoughts?
No, absolutely. So we absolutely know that if you're building agents and agents need to be smarter, they're not going to be smarter without having all the pieces of the data. In fact, more pieces of the data than what humans need many a times,
Hmm.
right? You really need to feed every possible thing that these agents would need for achieving their purpose. So take an example, for example, the same example that you took, which is, let's say I'm building a data analyst agent as an instance, right? And there are two departments, users from two departments, let's say sales and marketing. Now, if I actually know these users persona and what are the tables that they typically go after, what are the kind of business questions that they typically go after, then I can actually make sure that I nail down these tables depending on the persona that they have. Hey, this question is coming from the sales department, and maybe that is the reason why these are the tables that make more sense than the other ones, right? So as you start getting into the questions, you start saying that, hey, you just don't need the technical and business metadata, you also need the user interaction data, for example, right? If you have that history of how the user is interacted, you can better personalize the experience next time he's going to ask a similar query, right? So all of that really is where the intelligent data platform has a role to play. And obviously, you don't want to take all this directly to the agent, because at the end of the day, you need governance. You don't want to leave all the pieces of the data all over the place, right? So
Yeah.
intelligent data platform has a big role to play. It's already central to building many of the things, many of the applications around BI and the data science. And I think this could further accelerate as like the fabric for building AI agents
Yeah.
that we want to look at
You
it,
know,
right?
one thing that also became really popular this year is graph drag, although it's still work in progress. But one example I liked a lot was with a lot of metadata, I can start finding out if my content uh, is accurate or like sensitive information. Inappropriate content. I can do like in my emails, I can do all of that very easily. But what if I want to look at history of last 5 years of a user's interaction and and then start seeing, is there a pattern? So it's not just, is there offensive content in one email? Is there offensive
Yeah,
content in one email from a person over a period of 5 years? And for
yeah,
that, a graph becomes really important. And so I saw there was some movement in graph rack space, quite a bit of movement there too.
yeah, yeah. So I think the other two pieces in intelligent data platform that we should highlight is, as we talk about the unification, the unstructured
Hmm.
uh, we is going to play a crucial role, because a lot of 80% of enterprise data is unstructured today, and,
80%.
and this is across all the repositories
Hmm.
that may exist, from your Google Drives to OneDrive to Notions and all over the place, right?
Hmm.
And if you really want to build smarter agents, you will have to essentially extract value out of this 80%.
Hmm.
And the intelligent data platform again has a role to play there, where you bring in this textual data, the image data, the audio video data, all of that together into the data lake that you have, which is then governed, and all the important metadata extracted in the unified meta plane, and that essentially gets consumed by the agents or any of the AI applications that you build.
So that is actually a very next thing, which is ETL for AI. So that's a trend. But before we
Yeah,
go there, I think there are a few market movements that I want to bring to fore here. I have already given examples of what happened with the three hyperscalers. So let's move on. And also I mentioned Snowflake and Databricks. So those are the five big data platform providers. But then there are other ones too. There's IBM and Cloudera that are
Yeah.
also making a lot of movements in exactly the space of whether you call it a data fabric or intelligent data platform. But then there is a whole slew of companies that so far were focused in some particular area, like Salesforce was pretty much a CRM, but Salesforce Data Cloud is now going to be as important a player as all these other ones we have mentioned. ServiceNow is coming into this space, Palantir. So there are a lot of these players. But then there's this dark horse of companies that today are not in the data platform space, but if they buy a few database companies over the next year, then they may be. And these could be NVIDIA, OpenAI, which actually already bought Rockset, although they didn't get into the space, Anthropic. So those could be the new vertical stack where they're starting from models and frameworks and may actually go into managing data. What do you think?
No, I think you're right. And a good analogy here would be the automobile industry and the data. I mean, we're more beyond MDS. We are not going to anymore go by point solutions. That's
Hmm.
a clear thing. So now you come to this fact that you will buy an automobile, which is like a fully made car. Having said that, there's going to be a lot of competition here because we're talking about a huge canvas of features
Hmm.
as a whole, right? So you're not talking about point solutions anymore. You're talking about a lot of features here, and from a customer standpoint, maybe a lot of them won't make sense for one customer, but would make sense for another one, right? So
Yeah.
in a sense that, and then there is a question of the other requirements that you may have: privacy, security, where does the data lie, what is the pricing model, whether it's subscription based or an ownership model, so on and so forth. Which cloud? We have a problem with a lot of these platforms have basically native to the platform vendor in many cases. There
Hmm.
are very few options where you could potentially be cross cloud essentially, right? There's also a question of the pricing model, right? So there are a lot of other factors that would come into play when the customers are choosing the platform that they need, and this is going to start revealing more like an automobile market where there's a lot of diversity of features. Uh, you know, Starting from your softer features like your music system to everything, right? So the UX, for example, the UX is a huge opportunity across the platform even today,
Hmm.
right? So my sense is that the story is going to play out. This is going to further expand. The customers know that they would need an intelligent data platform as the base layer. So they will go out for that, and they will also become discerning on what do they need specifically within that as we go further.
Yeah, that multi-engine will become really big. So
Absolutely.
let
So, yeah,
yeah.
go
So
ahead.
I think we should, in the interest of time, so we have so much to talk about. So
Yeah.
let's talk about the next trend, which is this unstructured data and what's happening there.
Yeah. Look, we just discussed that unstructured is 80% of all the data that you
Yeah.
have today. This is after really mining, transforming, enriching structured data for almost multiple decades now,
Hmm.
right? So unstructured still rules in the form of the natively connect source data that enterprises have. And with AI, what really has happened, and we've seen RAG as the first application that a lot of enterprises built in 2024, this is really possible to mine with AI, right? So what this pattern really is helping us do is again bring in a structure to how do we connect many of these repositories back into the agent. And the pattern that we're talking about here is basically extracting the repository from various siloed repositories that you have across the enterprise. Then you transform them, prepare them, clean it up, update metadata, identify key entity relationships, right? And then load it into your data lake and the vector store or potentially a graph store,
Hmm.
right? So that's really a pattern. And the reason why this pattern makes sense to have a separate slide beyond the intelligent data platform is because there's a huge volume of data, and this alone might need scale by itself. for enterprises to really make the most of all the data that they have.
Very nice. That is great. So a lot of, and there are a lot of companies in this space. I know we've had LangChain, Llama Index,
Yeah.
Unstructured.io. So you see new companies coming up?
I'm sure there are many. I mean, I don't have the names on my mind, but yeah, there are going to be more here in this space. There could potentially be the structured ETL guys also potentially moving into the space
Yeah.
because that gives them an opportunity to grow.
To actually, if you're going to feed a unified data plane with structured and unstructured data, then the ETL vendors or ELT or whatever it may be, they also should support
Yeah,
structured and
yeah,
unstructured.
yeah,
So that takes us to the last one, data readiness for AI. And I know you and I struggled quite a bit with this one when we were writing our document because we were like, we are already doing this stuff. Why is this a trend? And so, but there are a few interesting things that we discussed. So do you want to
yeah,
talk about these?
yeah, yeah. So, look, if we go back and look at 2024 trends that we did have data observability in 2024. We also had data products in 2024. So, again, there is this particular slide is sort of merging the two along with some additions that we have, right?
Hmm.
Now, we've said that data is the is the backbone for success with AI agents. Now, as we all know, garbage in is going to produce garbage out, right?
Mhm.
So your agents are which are already uh, going to be unreliable because of the stochastic core. If you're going to feed them wrong data, inaccurate data, old data, stale data, right? This is going to substantially alter the user's experience with the agents and the value of those agents,
Hmm.
right? So we again going back and saying, hey, if you're an enterprise who is actually going to be building agents, it's important to look at how does your data fabric look today across all the dimensions that we mentioned here: trust, freshness, correctness, completeness of metadata, lineage, legality, bias, relevance, versioning, all of that. Right? There could be more essentially, but whatever makes sense, they just don't need to make sense for a given specific artifact. They need to make sense over the duration of or the life cycle of the agent while this data is going to be consumed, which means version after version, artifact after artifact, so on and so forth, right? So making sure that your data quality slash observability process is streamlined and you can trust it is going to be super important for you building valuable, reliable agents. That's like table stake, right? So that's really that pillar. And this pillar further expands in the canvas because now you're not talking about just a structured data. You're also talking about all of these dimensions to be working for the unstructured or the other data formats that you're accumulating, right? So that is really that pillar of data readiness. You need to take a serious look at it if you want the agents to actually have good chance of success in deployment. That's the first part. The second part is data products. Again, this is not new, but last year when we talked about data products, we talked about from a structured point of view.
Yep. Correct.
But this year we're bringing in the fact that a lot of the data products or the altered data, the transformed data that you have. Let's say you've got a PDF, you've converted into various segments of documents. You've created an altered version. Let's say you've created a brief, or let's say a chain of thought data set, or a distilled data set, right? A smaller data set because we want the prompt to be smaller for consumption, right? So when you're doing all of those transformations, they are data products because they're going to be consumed by an end consumer, right? So we are looking at a lot more newer form of data products as which are going to be exclusively consumed by agents. Now, there are two ways they will consume. One is they will consume via a new fine-tuned model that you're going to build as an enterprise, or they will go directly into the prompts of many of the agents that you're building, right? In either of the two cases, these data products have to be high quality for you to really get the desired results.
So can I take an example? If
Yeah,
within my organization, if I have a lot of training videos, and they're all
yeah,
over the place, and some are on YouTube, some are on my website, and I say, let me extract the data from five, six of these videos and create a frequently asked questions or a study guide. That's a data product. That's an AI based data product that used unstructured data, used
Yeah.
an LLM, and then created some sort of an output.
Absolutely. So any derived from, and this is very interesting. And I'll take another example since we talked about it. I mean, the one of the most popular announcements from Google in 2024 was Notebook LM,
Hmm.
and we saw that every document or every URL that you basically present to it, it actually gives you an option to create a various briefs out of that, which are more consumable to create the audio conversation essentially,
Yeah.
right? And that's a classic example of the fact that the data, I mean, data itself has its own loop. You basically create a new form of data, you use that to create another form, and then you could potentially use that and something else and feed it to the agent, right?
Hmm.
So this whole loop that we talk about is can get really complicated, and therefore managing them through the data pipelines or the web of data pipelines that you're going to be building is going to be super important. That's really where the data products play the role. Uh,
Hmm.
uh, that we're talking
Sounds
about
good.
here.
That's great. All right. So that takes us to Moonshots, which is a final category. Three things here: cognitive agents, embodied agents, and agent networking. So let's go through these, and we'll start with cognitive agents. So what is a cognitive agent?
Yeah. So we talked about agents that we're going to be starting to build, which is essentially about expanding the frontier of automation that we were going to do. A lot of these agents are going to be likely narrow agents, specialized agents that we're building, right? And we said there are four characteristics that these agents would have, which we're building earlier. One of them is perceive,
So
break it
we
down.
said so the four that we started earlier were sense, reason, plan, and act. Those were the four characteristics. And now we're adding
Yeah,
a fifth one,
yeah. And
and
that
that
fifth
is
one, we will call it just self improve, right?
self-improve.
Uh,
Okay.
so the whole
Hmm.
idea here is like humans. I mean, you're not going to be a perfect data analyst on day one. You, as you enter the enterprise, for example, right? You're going to go through your constant learning, improve day
Hmm.
on day, so on and so forth, right? So what you're doing on the job is you're upgrading your skill, you're upgrading your knowledge, so that the next use case or the problem that you're working on, you do better than the previous one that you did,
Yeah.
right? And cognitive agents really bring in that piece, which is can these agents really learn and improve by themselves, essentially, right? Can we really build agents which are not just doing the task as we have stitched them or trained
Yeah.
them for
Yeah.
initially, but
Yeah.
also improve by themselves over time? And that's really
Yeah.
what this piece is about.
Yeah. That is great. So let's move to embodied agents. So what is an embodied agent?
Embodied agents are just agents which can be in a physical space, in a physical body, potentially, like robots, for example,
Hmm.
right? So we've taken a few examples here in this slide. Let's say you're a bank or financial services, and you have a branch and you want a customer support robot to be receiving all the customers, for example, right? So a customer support robot in a branch can potentially receive the customer, understand what are the needs, maybe route it to the right uh, uh, teller or the counter, or potentially even help with the transaction if it is in scope, right? So that could be a good example of an embodied agent. uh, for example, in another context like a retail, you could have a shopping assistant agent, for example, which could again receive the customers,
Hmm.
help understand their need, maybe route them to the right aisle where they can find things that they need, right? Even help them with choosing potentially as a personal assistant,
Yeah.
right? So all of these are expanding the use cases for enterprises which meet their customers, or which probably have a factory automation workflow,
Yeah.
Each of these could potentially be examples of embodied
Yeah,
agents.
brilliant. Very nice. So we've talked about these agents a lot, multi-agent. We had referred to like how the agents communicate. So what is the agent networking moonshot trend?
I mean, this essentially comes from my own background. I mean, I've lived through the days when we built the BGP protocols and the internet protocols,
Hmm.
and how we moved from internet, from DARPANET to intranet to internet of the day that we have today is all built on open standard protocols, essentially. Now, when we talked about the multi-agent systems, these systems do have multiple agents, but the way they connect or the way the tasks are delegated are essentially pre-planned or pre-programmed by the developer of those systems, which is in a
Hmm.
closed loop, right? Here, what we're talking about is agents which are built by two different enterprises, or let's say two different entities within the enterprise. And I am an agent. I have built an agent which is pretty good at planning, let's say, planning, let's say, a travel planner, just taking an example. And you have built an agent which is essentially good at onboarding the customers and understanding their needs. Now, let's say a customer comes to you and says, "Hey, can I get? I want to plan my next holidays, and can you help me with that?" Now, as an agent, you're not tuned to that, but can you then reach out and find out who is the best travel planner agent, for example, that I can reach out to, right? And then you get a list of, let's say, top three or four planner agents over the network, and then you take their services essentially to help out your customer take that decision on how well can he plan his travel,
Yeah.
right?
Yeah.
So this is a good example of where agent networking works, where one enterprise does not have to build all the agents,
Yeah.
uh, and they can potentially be built by different enterprises,
Yeah.
and you consume the services over the internet.
So Anthropic recently came out with MCP, Model Context Protocol, and there's again a lot of interest in that, but that is not agent to agent, right? That's
That is, yeah, that's true. That is an agent to tool protocol. In fact,
tools. Yeah.
what I jokingly call it is, even before Anthropic came up with MCP, we had this concept of ACP, which is an agent communication protocol,
Hmm.
which is an agent to agent communication protocol,
Yeah.
right?
You
So MCP is more of an agent tool interface,
Yeah.
essentially.
You know how important this lack of this communication protocol can, how detrimental it can be. It reminds me, my friend Juan Cicada was sharing this with me. He shared with me the early 2000 research paper that Dr. Tim Berners-Lee had written on semantic web or Web 2.0. If you
Mhm.
go back to that, it starts with agents. I have an agent that reads my email. I have an
Yeah.
agent that. So he was the creator of World Wide Web was talking about agents in 2001,
So,
but the
in
reasons
1990s, early days, we used to call them
1990s.
expert systems.
Wow,
Uh, so there was another term in 1990s called expert systems.
expert systems. Correct.
Yeah,
But the reason, so Warren was telling me the reason why semantic web failed was because there was no communication protocol
yeah,
that existed. So I think that's why this trend of having
yeah.
some protocol is born. And that takes us to the end of 2025 data and AI trends. And we'll be doing a lot more content in this space, but we will recap here. You looked at these different ones. But with this, we're going to end here. Thank you so much, everyone, for joining. This was amazing. And until next time, we will talk to you soon. Thank you for dialing in.